Guys, so oh boy, all right, I'm doing this right before going to bed basically. So not sure why you have to know that, just in case I my tiredness comes through. Anyway, this is the T-score practice. Obviously at the top it says that I put up there on Canvas, and we said I'd have the answer key for. Let me double check my audio. Okay, everything should be good. So degrees of freedom again is n minus 1. So in this case, on this first problem, it would be 6 minus 1. Let me see if I can make this work. So that would give me 5. So degrees of freedom is 5 for this problem. And so now I know degrees of freedom is 5, 99% confidence. So I know that it's 1% in 2 tails. So if I take a look, let me see if I can pull this up. Bam. T-score chart. 1% in 2 tails, and I want to stop at 5. So I get 4.032. 4.032. I like it. Pull this back in. Okay, cool. And again, just so you guys realize, I tell you right up here, find the t-scores, assume normal distribution with S known. Right? You cannot get the t-score unless you know it's a normal distribution. Just the same thing as the z-score. You can't get the z-score unless you know it's a normal distribution. You can't use the chart. So I know it's a normal distribution, so it doesn't matter the sample size is so small. The second one, the sample size is big enough, so even if it wasn't normal, we'd be good, if I'm talking about the sample means. Now I know that I have 10% in 2 tails, 90% inside, 10% outside in the tails. Degrees of freedom, of course, I'm going to stop writing minus 1 because we know degrees of freedom is n minus 1. So that's 100. And now I can look up the t-score. Let's see. So I know degrees of freedom 100, and I want 10% in 2 tails. 10%, 2 tails. So I'm in this column, and I stop at 100. Bam, 1.660. There's 100. Bam, 1.660. That's the t-score I would use for whatever the application is. Kerbam. This one is going to be a little more interesting. The degrees of freedom for this one is technically 92. But if you look at the chart, and I want 98% confidence, which means alpha is 0.02, right? 2% in 2 tails, 2%. So I can see my 2% in 2 tails right there. But when I try to find 92, oh, shit. So what you always want to do, pretty much always, is if the degrees of freedom isn't on here, you go down further. So I'm at 92, I'm going to go to 90. 2.368. You always kind of penalize yourself for something you don't know. So you're going to make the t-score a little bit bigger. So I'm going to use 2.368 for that t-score. Bam. All right. That's the first problem. Sweet. I could be doing those in red, but too bad. You were with me when I was doing them, so you know what the answers are. This one now, let's do this first. Which one of these cannot be done? Let's identify that one first. This has got too small of a sample, but it's normal. So I don't need a sample of greater than 30. I can have anything. This one, it's not normal, but the sample size is big enough, right? This one is not normal, and the sample size ain't big enough. So part C, let me do that one in red. Part C can't, oh, you can do it, Jeff, be done. Oh. And the last one can be done twice over. It's normal and the sample size is big enough just in case. So the other 3 I can do. So the whole point of this number 2 is, am I using a Z or am I using a T? So I know I can do something in A, B, and C. They're all normal for one reason or another. What tells me if it's a Z or a T is which standard deviation do I know? So in this part A, I know the population standard deviation. Therefore, I can use a z-score. You can do it, Jeff. You can do it. There you go, buddy. And notice this asks me to find the appropriate score. We do this in nifty red and bold it. Yeah. Sorry, I'm getting loopy. And make it bigger. Bam, bam, bam. All right, so now you can see better. So the z-score, now here's the interesting thing. I didn't talk about this I talked about this a little bit in one of my stats classes. If you go look all the way to the bottom, now I mentioned this quickly in one class. Do you see how the t-scores are getting smaller as essentially my sample size is getting bigger? Because the bigger my sample size, the less I have to cover for myself, because the more confident, the more certain I am, let me use that word, the more certain I am in the standard deviation that I find. The bigger the sample, the better the S is as the estimate for sigma. Okay, sound a little bit drunk, but I assure you I am not. I'm just tired. Or maybe I am, I don't know. I gotta walk a line. If you'll notice the very last line, if I have a large, you gotta love that. If I have a large sample, I can essentially use z-scores. These are all z-scores, 1.645, 1.96, 2.575. It's actually 2.576. That was an estimate used from the z-score chart. Those are z-scores down there. So this chart kicks ass. So basically, if I stop somewhere at a degree of freedom, I get a t-score. If I go all the way to the bottom, I get a z-score. So let's come back to this. I want 90% confidence, and it's a z-score I can use. So alpha is 10%. There's 10% outside, right? So I can use a z-score. So let me go to 10% and 2 tails, and I'm just not going to stop. So I make sure I don't get a t-score. These are all t-scores. There's my z-score, 1645. That is a very familiar z-score. Yeah, Jeff, you're not in Europe or something. Let's use, there we go, buddy. Okay, so just for the formatting, I'm going to do this. Okay, but this one, I know I'm going to use a t-score. How do I know I'm going to use a t-score? Because I know S. I don't know sigma. I only know S. And that's what t-scores were invented for, was when I don't know the real standard deviation. I only have an estimate. I only have a sample standard deviation. So let's see. I know alpha is 0.02. What's my degrees of freedom? Again, excuse me. Degrees of freedom is 38. All right, Jeff, whatever. Degrees of, all right, stop it. That is 38. Just not going to say degrees of freedom. Oh, sorry. 38. I know alpha is 0.02, right? 0.02, 2% in 2 tails. 2% in 2 tails. Bam. 2% 2 tails. Stop at 38. Bam. So 2.429. That is the score I would use. Was it 2.429? Was that your card? I hope so. We already did C. Can't be done. But just to really make sure. You see how I knew sigma? And it's normal. Z-score. It's normal because the n's greater than 30. I don't know sigma, therefore t-score. That's how you tell which one to use, is which standard deviation do you know. So the last one is normal for damn sure. I know S, I don't know sigma, therefore I must use a t-score. So let me copy this down here just for the formatting. Yeah, there. Let me take this away. That's the other answer from earlier. So I know that alpha is 0.01, 1%, right? Alpha is 0.01. And I know degrees of freedom. Let me write this down here. Degrees of freedom. Hey, I just said it normal a second ago. Degrees of freedom. There it is. I can do it. Degrees of freedom. Stop. Degrees of freedom is 60. Now it sounds Swedish. Let's see. 1%, right? 99% inside, which means 1% in 2 tails. And I want to stop at 60. 1% in 2 tails. I want to stop at 60. 2.660. 2.660. Where'd it go? There it is. There it is. 2.660. I like it. All right. Now this last thing, all right, let me pause the recording. I'm going to throw this in my calculator real quick. I forgot to do that before I did this. Let me pause. Okay, so I put those in the list one. Then I got one var stats, and it tells me that X bar is, let me make this red and bold and big. Okay, X bar tells me is 78 point, I don't tell you how many decimal places, so let's do 3, 78.286. And I know that S is 15.724. I have to round that, right? Point, Jeff, you could do it, buddy. 0.27. Oh, you could do it, Jeff. 724. Come on, buddy. Let's get through this. You can do it. All right, good. That's all that asked me for. Is that first part is it just asked for the X bar and the S. So hopefully you remember about one var stats. It's been a little while, but we did a decent amount of that before. So what I'm missing is the t-score. Now, obviously, I kind of gave it away here, but why do I have to use a t-score? Because I don't know sigma, right? Yeah, and really quick, notice how I say it's from a normal distribution, so it doesn't matter the sample size is small, it's already normal to start with. So my degrees of freedom, hey, look at me, I said it normal. They are, bam, bam, you can do it, boom, boom, there it is. Degrees of freedom is 6. Maybe if I get tired, I just stop doing it. And I know I want 98% confidence. So alpha is 0.02. There's 2% in two tails. So if you look up on the chart, 2% in two tails, 2% in two tails, and I stop at 6, 3.143. 3.143 is the t-score I want to use. I already forgot it. 3.143, is that it? I'm going to have to go back and check. Do the hills are alive? There it is, 3.143. Good job, Jeff. All right. Let's see. Red, bold, big. So now let me throw everything I know. X bar I know is 78.286. Give or take. So this should feel very much like any other confidence interval we've done. Just the number I just put in is a t-score instead of a z-score. Not a big deal. Times the standard deviation. So times, where'd you go standard deviation? 15.724 divided by the square root of, get in there, n, which is 7. And one big mistake is people put 6 here. People put the degrees of freedom. The formula says n, right? The formula says n. So put n there. So then if I do the, what do you call it? The error, let's see what I get. 3.1, get in there, 0.143 times 15.724, square root of 7. Let me see, does this make sense? Yes, I see. Boop. Yeah, okay. 18.679, that's what I get, 18.679. So then if I add and subtract that from 78 point, get in there, 78.286 minus that, 78.286 plus that, I get 59.6 up to 96, well, 97.0. And then our statement would be, we are 98% confident, you can do it, Jeff, that the, let's see, interval, what was the units here? Grades, 59.6, so there's no real units on this specific problem, to 97.0, contains the true mean grade. I didn't say from what population, so it contains the true mean grade. This is as much as we can say, right? Let me see if I can't get it all up there. Yay. Now notice, this interval sucks. So anywhere from an F to an A. And of course, why does it suck so bad? For a couple different reasons. We don't know the population standard deviation, so we had to use a bigger t-score, not the z-score. Our sample size was so small, right? and that made the t-score even bigger. So it's so many things working against this poor little. So we'd have to take a larger sample to decrease the error in our estimate, in our interval. All right, is that enough? Yes, so that's that for that. I like it. Tomorrow, tomorrow for some of you guys, well, it depends on what time you're watching this, to be honest, but anyway. Next thing we'll do is this thing down here. All right, so let me get this loaded up so you can look at it. Oh, let me see here. Stop sharing. Look at me. And I will stop.